All right. Section 10.5 is about inverses of matrices and matrix equations. Inverses of matrices and matrix equations. But first, let's discuss what we mean by identity matrix. It's like the identity for multiplication in real number. If you take 1 times it by any real number, you get that real number. Any real number times 1 is A. Is there such a matrix? When you times it by another matrix, nothing changes. That's what we're looking for. There is actually. There is what we call the identity matrix. It's a square matrix with ones at the main diagonal, ones at the main diagonals, and zeros everywhere else. This is 2 by 2. And then a 3 by 3 identity matrix. Again, 1 along the main diagonal and zeros everywhere else. So you can see ones here. It's a 3 by 3. And so on. 4 by 4. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 1. If you take any identity matrix and times it by any other matrix, you get that other matrix. So we use I for identity, and then we can put the units, the order at the bottom. So any identity matrix times matrix A equals A, and then if you do A times I is A for any square matrix A. Okay. So let's check that. Let A be a 2 by 2 matrix. 2, 3, 4, negative 1. So the identity matrix that corresponds to that, it's a 2 by 2, so it's 1, 0, 0, 1. So A times I2 or I, if you don't want to write I2, that's fine. 2, 3, 4, negative 1, 1, 0, 0, 1. So remember to multiply, you have to have these numbers are the same. They are. And the outer values are going to be the new order, 2 by 2. So we take row times column. 2 times 1 is 2, plus 3 times 0 is 0. Then 2 times 0 is 0, plus 3 times 1 is 3. Then this times the first row, column. 4 times 1 is 4, plus anything times 0 is 0. Second times second. 4 times 0 plus 1 times negative 1. And you can see it's going to be exactly matrix A. Okay. Okay. What is the inverse of a square matrix? The inverse of a square matrix. You know, if you recall the multiplicative inverse, like A times 1 over A is 1. 1 over A is the multiplicative inverse, which is the reciprocal, like A over B times B over E is 1. So in the case of a matrix, what do we times A by to equal the 1 for the matrix is the identity. There's such a matrix B. When we times it by A, we get the identity, or B times A. If we can find that matrix B, that's called the inverse of A. Okay? Inverse matrix of A. So let me write it more formally. Let A be a square matrix. So we're only dealing with square matrix when it comes to inverses of order n and rows and columns. If there is a matrix B of the same order as A, of order n by n, such that when you multiply them together, you get the identity. Okay, B times A equals I. B is called the inverse of A. And we write A inverse. Okay, so if we can find a matrix A, matrix B, when we times it by matrix A, we get the identity. That matrix B is called the inverse of matrix A. If a matrix is non-square and it doesn't have an inverse, a non-square matrix has no inverse. So the matrix, and it's necessary for the matrix to have an inverse is to be square. And once you find the inverse, that's it. If we both find inverses of the same matrix, we better have the same answer. The inverse of a square matrix is unique. The inverse of a square matrix is unique. Okay, so number 6, page 732. They want us to check that these two matrices are inverses of each other. 2, 1, 12. Matrix B, 9, negative 10, negative 8, negative 12, 14, 11, negative 1 half, 1 half, 1 half. So let's find AB. I'm going to do matrix multiplication, and at the end you can check your calculator. Negative 10, negative 8, negative 12, 14, 11, negative. So we take 3 by 3 times 3 by 3, we're going to get 3 by 3. Row times column. 3 times 9 is 27 plus negative 24, and then 4 times negative 1 half is negative 2. Row times column. Negative 30, 2 times 14 is 28, 4 times 1 half is 2. And then first row, third column, negative 24 plus 22 plus 2. And then we'll do second row with all the columns. 1 times 9 is 9, minus 12 plus 3. Again, second row, second column, negative 10 plus 14 minus 3. And then negative 8 plus 11 minus 3. And then third row with all the columns. 2 times 9 is 18. 2 times negative 12 is negative 24. I'm sorry, 1 times negative 12 is negative 12. And then 12 times negative 1 half is negative 6. 2 times negative 10. 1 times 14, and then 12 times 1 half is 6. 2 times negative 8. 1 times 11, and then 12 times 1 half is 6. That equals, that's 1. Negative 2 plus 2 is 0. Negative 24 is 0, and then 0. That's 1, 0, and 0, 0, 1, which is the identity matrix. You can do, I did A times B, you can do B times A, and you can see that. And you can actually have your calculator do the math for you, but remember, you gotta show me the work on the test. This is only to check your answer. So you go to second X inverse, to go to matrix, you wanna edit matrix A, it's a 3 by 3, 3 enter, 3 enter, and then you're gonna keep the matrix A, 3, 2, 4, 1, 1, negative 6, and then 2, 1, 12. And then we're going to exit and then come back to the matrix. We're going to edit, but this time matrix B, want it to be 3 by 3, 9, enter, negative 10, enter, negative 8, enter, negative 12, 14, 11, negative 1 half, negative 1 half, and 1 half again. Let's exit and then do second matrix. We want to do matrix A, so we stay under names, hit enter, and then matrix B, number 2, and there's the identity. If you reverse it, second matrix inverse B, second matrix inverse A, and there we go. Okay. Now, how do we find the inverse? So we were given the inverse, right? These are inverses of each other. So what if we only have A and they tell us find its inverse B? How do we do that? Okay, we're gonna start with the 2 by 2 because there's a formula for that, and then 3 by 3 and higher, it's a lot more work. So finding the inverse a 2 by 2 square matrix. So this method only works for 2 by 2 square matrix. So if matrix A is a 2 by 2 matrix A, B, C, D, then its inverse is given by the formula equals 1 over AD minus BC times the matrix that you obtain from A by flipping the entries along the main diagonal. So instead of AD, it will be DA. Then do the opposite of these entries along the secondary diagonal. So negative B, negative C. If AD minus BC equals 0, this is, by the way, called determinant of A. You will see. Of matrix A. If that quantity is 0, then A inverse does not exist. We say we have a singular matrix. Singular matrix A, meaning matrix A has no inverse. Okay? If when you do 1 over AD minus B and you get 1 over 0, that's undefined. That's automatically saying the inverse does not exist. And the matrix A is singular because it doesn't have an inverse. If it has an inverse, it's called non-singular. Okay? 14, page 732. Matrix A is negative 7, 4, 8, negative 5. Its inverse, so let's write the formula. 1 over AD minus BC. And then you flip these, you do the opposite of those. So 1 over AD, negative 7 times negative 5 is 35, minus 8 times 4 is 32. As long as that quantity is not 0, we're good. So it's 1 over 3, right? So a scalar times a matrix, you divide the scalar, so you get 1/3 times negative 5 is negative 5/3, 1/3 times negative 4. 1/3 times negative 8 is negative 8/3, and 1/3 times negative 7. And we can check our work on the grapher. So let's key in matrix A. So we're going to do second matrix edit. We're going to edit matrix A. It's a 2 by 2 this time. Negative 7, 4, 8, negative 5. And we're going to quit. And then we'll go back to matrix, retrieve matrix A. And then the inverse key is right there. Right there, X inverse. Right there. So just hit that. Then hit enter. It's going to give you a decimal. I'm going to switch it to fractions. So go to math. And then hit enter twice. Okay, enter twice. And there's the answer that we got. Okay. Again, this is only to check your work on the test. I need to see the work. No work, no edit. It's recorded now. All right. So what if we have a higher than 2 by 2? The inverse of 3 by 3 and higher order square matrices. So if A is an n by n square matrix, then to find its inverse, first you want to write the augmented matrix A on the left side, and then the identity matrix that corresponds to A on the right side. If A is 2 by 2, then you write the identity for 2 by 2. It's 2 by 3, you write the identity, and so on. Then you want to use elementary row operations. Remember the elementary operations? Interchanging any two rows, multiplying any row by a non-zero constant, or adding a multiple of one row to another row will not change the augmented matrix. Okay, so you can use any of these three elementary row operations. Use elementary row operations to change the matrix. Into, you want somehow to have the identity on the left. You started with the identity on the right, you want the identity on the left, and whatever left on the right side is going to be the inverse of the matrix. Okay, it's a long process, but it's doable. So here's an example. I did some of it. I'm not gonna actually, it's done for you. Number 18, page 732, but I'm gonna redo it so you can understand that, so you have all the work in there. Number 18, page 732. Find the inverse of the matrix A, which is 4, 2, 3, 3, 3, 2, 1, 0, 1. Of course, we can get the answer in a second by putting it in the calculator, but not learning. Okay, so the first thing we want to do, we're going to write matrix A, and next to it the identity matrix. So 4, 2, 3, 3, 3, 2, 0, 1, and then the identity matrix, which is a 3 by 3, 0, 1, 0, 0, 0, 1. So our objective now is to get all this to be over here, meaning we're going to need a 1 and then zeros below, 1 in the middle, 0 below and above, 1 here, zeros above it. Okay, only by using elementary row operations we can do that. The first thing we can do here is to swap rows 1 and 3. You can see why, so we can get the 1 up there. So let's do that. 1, 0, 1, 0, 0, 1, and then 3, 3, 2, 0, 1, 0, and then 4, 2, 3, 0, 0. Now I want to make the 3 a 0 and the 4 a 0, so I'm timesing the first row by -3 and adding it to the second, and then I'm timesing the first row by -4 and adding it to the third. Okay, so the first row is the only row that's not going to be changed now. So -3 plus 3 is 0, -3 times 0 is 0, plus 3 is 3, -3 times 1 is -3 plus 2 is -1, 0 plus 0 is 0, 0 plus 1 is 1, -3 plus 0 is -3. -4 plus 4 is 0, 0 plus 2 is 2, -4 plus 3 is -1, 0 plus 1, 0 plus 0, and then -4 plus 0 is -4. So we got the 1, we got the zeros, and we want to have a 1 here. and then we already have a 0 up there, but we want a 1 here. So in order to get 1 here, I can times the third row. The easiest way I know, instead of timesing by 1/3 and get fractions, I can times the third row with -1 and add it to the second row. So it would be -2 plus 3, which is 1. That's all I need. So 1 0 1 0 0 1. So 0 2. Let me write the third row and then I'll do the second row. 1 0 4. So 0 plus 0 is 0. -2 plus 3 is 1. 1 plus -1 is 0. -1 plus 0 is -1. 0 plus 1 is 1. 4 plus -3 is 1. So we got the 1, we have the 0 up there, we need a 1 here, so we're going to times the second row by -2 and add it to the third row. So -2 R2 plus R3, I want to give it to R3. So you can see it's a lengthy process. There's nothing hard about it. The only 3 operations we can use are the elementary row operations, and it should work eventually, but you have to have a lot of patience and you're going to be careful with your calculations. So 0, -2 plus 2 is 0, 0 plus -1 is -1, 2 plus 1 is 3, -2 plus 0 is -2, then -2 plus -4 is -6. So we got the first column, the second column, the third column. We need a 1 down here. So the best thing that I know to make this a 1 is times the whole last row by negative. So this times negative is not going to change it. This will be plus, minus, plus, plus. You can use any row by any non-zero constant, and that's what I did. Okay. So now all I need is, this is a 0, all I need is to have a 0 up there, so we're timesing the third row by -1 and added it to the first row. So let's copy rows 2 and 3 first. 0 0 1 -3 2 6. So we're doing negative times 0 plus 1 is 1, 0 plus 0 is 0, -1 plus 1 is 0, 3 plus 0 is 3, -2 plus 0 is -2, -6 plus 1 is -5. So this is the identity for the 3 by 3, and this is the inverse. So A inverse is 3, -2, -5, -1, 1, 1, -3, 2, 6, and we have a calculator. We're going to check it. So we're going to go to second x inverse, go to matrix. We're going to hit matrix A, which is 3 by 3. Okay, 4, 2, 3, 3, 3, 2, and then 1, 0, 1. Let's exit, second quit, go back to the matrix, retrieve matrix A, and then inverse key, and there's your answer. Exactly what we got. Okay. Okay, now another application of matrices is solving systems of equations. Using the inverse of a matrix. Alright, for example, if I have 2x plus 3y equals 7, a system of equations, and we talked about that, we can actually change this into an equivalent augmented matrix. It's going to be ax equals b. How is that? We're going to write matrix A, which is the coefficient matrix, coefficients of x. coefficients of y, and matrix X is the column matrix XY, and matrix B is the coefficient matrix 7, 1. And you can see that this A times X equals B is going to be exactly the system of equations. If you do row column, you get 2x plus 3y equals 7, and then row column, negative 3x plus 4y equals 1. It gives you the second equation. So we're gonna use this system, use the inverse of a matrix to solve. Okay. Here's another example. Two x minus y plus z equals 1, x minus z equals 2, and y plus 2z equals 5. So we're going to write the coefficient matrix. There's no y here, so it's 0y. There's no x, so it's 0x. So we're going to write the coefficient matrix A, 2, 1, 0, negative 1, 0, 1, and then 2, no, 1, negative 1, 2. The X matrix now is going to be a 3 rows 1 column matrix, and the constant is going to be 3 by 1. That's B. Okay, so how do we solve it? This is what we're going to do. So to solve a system of equations using inverse of a matrix of matrices, the first thing is to write the system as we have done. Write the system of equations as then matrices AX equals B, and then apply A inverse to both sides from the left. So basically you have AX equals B. This is the left, this is the left. So you do A inverse and then A inverse. Because matrix multiplication is not commutative, so you gotta be careful. And then you do A inverse when it's matrix multiplication, it's associative, so you could do that. Equals A inverse B. That's the identity matrix. Remember, any matrix times its inverse is the identity. And we also saw that any matrix times the identity is like 1 to matrices, so X equals A inverse B. So to find X, Y, and Z, or X, Y, you take the inverse of the coefficient matrix times it by the constant matrix. The inverse of the coefficient matrix times the constant matrix. Okay, to find the inverse only for this part, I would allow you to use the graphing calculator. I wouldn't need the work, just for this part. Okay, because I would have asked you finding the inverse previously. There should be one question on the test where you actually have to show the work. So it's pointless to show the work again in this one. So here, I would say on the test also this, look, use graphing calculator, okay? It will say use graphing calculator and matrices to solve 2x minus y plus z equals 1, x minus z equals 2, and y plus 2z equals 5. So I want to fill in for my missing variables, fill in zeros so we don't miss those. So we want to write it as a matrix. So the coefficient matrix is going to be 2, 1, 0, negative 0, 1, 1, negative 1, 2, the x, y, z matrix, and then the constant matrix. So A times x equals B. To solve it, we're going to do, remember, A inverse from the left. That's going to be the identity, so x equals A inverse times B. So in order to find the x, y, and z, we want to find the inverse of the coefficient matrix times it by matrix B. Okay, so basically we're going to find the inverse of this times set. How are we going to do that? We're going to let the calculator do that. So here, so we're going to find the inverse of 2, negative 1, 1. So let's edit the matrix. 2, negative 1, 1, and then 1, 0, negative 1, and then 0, 1, and 2. Okay, let's exit that. Let's now be in matrix B, 3 by 1. Let's edit matrix B, which is 3 rows, 1 column, and it's 1, 2, 5. Now we're gonna retrieve matrix A. We're gonna do its inverse, and then we're gonna times it by matrix B, and that's gonna give me the answer. So x, y, z, so big X equal 2.4, 4.2, 0.4. Remember what big is? It's x, y, z. So x is 2.4, y is 4.2, and z is 4. Okay, that's another method of solving any system of equations using matrices, and you can solve any huge equation with technology in a few seconds right now. Okay, and that's it for 10.5.